Alright, in this video we're going to look at some examples of using the special product formulas for multiplying polynomials. So I just did another video where I kind of explained what these special product formulas are and kind of how they work. Here we're just going to do a couple examples using them. So the first one, we have 3x plus 5 squared. Right, so the special product formula that goes with that is a plus b squared equals a squared plus 2ab plus b squared. Right, so if I use that formula to do this, well, the 3x here corresponds to my a, right, and the 5 corresponds to my b. All right, so if I'm doing 3x plus 5 squared in this formula here, the a plus b squared, well, that equals a squared. So the first term I have, the 3x, gets squared, right? So it's 3x squared, and then it's plus 2ab. So it's plus 2 times my a, which is the 3x, times my b, which is the 5, right? And then plus the b squared, right? And the b is 5. Right, so that's just taking my a and my b, right? Again, the 3x is like my a, the 5 is like my b, and just putting them into that formula. Right, so it's the a squared plus the 2 times a times b plus the b squared, and then I just need to simplify this. All right, so 3x squared. Right, now I have multiplication inside that parentheses there being raised to a power, which means I can distribute that exponent to everything inside that parentheses. Right, remember, I'm allowed to distribute the exponent when what's inside the parentheses is either multiplication or division. I cannot do that up here when what's inside the parentheses is addition or subtraction. Right, again, knowing those rules with the exponents is very important. Right, so 3x in parentheses squared equals 9x squared. Right, remember, since both of these are in the parentheses, both the 3 and the x have to get squared, so it becomes 9x squared, not just 3x squared. Right, so 9x squared plus 2 times 3x times 5. Well, 2 times 3 is 6, 6 times 5 is 30, so that's going to be plus 30x, and then plus 5 squared, that's plus 25. Right, so that's using that special product formula, squaring a binomial to get to my answer. Right, so like I mentioned on the other video, learning these formulas is not crucial to be able to answer this question. If you completely forget what this formula is, or you find those a's and b's confusing of what to put where, and do I include the 3 and the x and all that stuff, you don't have to use that formula. Right? To get the answer to this another way, all you really have to do is, well, 3x plus 5 squared means I have a 3x plus 5 multiplied by another 3x plus 5. Right? I have that parentheses squared, and then just multiply that out. Right? If you do the FOIL method, 3x times 3x is 9x squared. Right? 3x times 5 is going to be 15x. 5 times 3x is another plus 15x. 5 times 5 is 25. And when you combine those 15x's together, you get 9x squared plus 30x plus 25. And actually, I think it might have been quicker to do it this way than to use the formula and plug all that stuff into the formula and do it like that. Right? So like I said on that other video, the formulas are nice to know, and sometimes they're helpful. Like when you have one of these where it's like raised to the third power, the formula definitely makes it quicker to do. But when it's one of these ones raised to the second power, like when I'm actually doing these problems myself, I don't ever really use that formula. I would just say, oh, this squared, 3x plus 5 times 3x plus 5, multiply it out, there's my answer. Right? To me, it's quicker to do it that way than to use this formula, and then it's also one less formula that I have to memorize. Right? So again, these formulas, they're nice, but they're not necessary. All right, so that's my 3x plus 5 squared, 2 different ways to come about it. The next one here, x squared minus 2 raised to the third power. Right, so here, the rule for raising a binomial to the third power, right, a minus b to the third equals a to the third minus 3a squared b plus 3ab squared plus b to the third. All right, so in this case, my a is like the x squared, and my b is the 2. Alright, so that's my a and my b. So if I'm using this formula, it's a to the third power. So it's my x squared raised to the third power. Then it's minus 3a squared, so x squared squared times b, which is 2. Then it's plus 3a, which again is x squared, times b squared, so that's going to be 2 squared. And then it's plus b to the third power. So then plus 2, sorry, that should be minus b to the third power. I had that written wrong up there. So it's going to be minus 2 to the third power, right? Yeah, that last one should be a minus b to the third. All right, so again, I identify, well, this is a binomial raised to the third power. There's a formula for this. My a is the x squared, my b is the 2. I just take, everywhere there's an a here, I put the x squared. Everywhere there's a b, I put the 2. And now I just have to simplify all this stuff. All right, so x squared to the third power. Well, going back to the rules of exponents, when you have a power to a power, you multiply those. So this is going to be x to the 6th power. Right, 2 times 3 gives me the 6. Right, minus 3 times x squared squared times 2. So first of all, the minus 3 times 2 is going to be minus 6. X squared squared is going to be x to the 4th. Once again, a power to a power, I multiply 2 times 2 to get that x to the 4th power. All right, then it's going to be 3 times x squared times 2 squared. All right, well, 2 squared is 4. 4 times 3 is going to be 12. So it's going to be plus 12x squared. Right, remember, when we're multiplying the 3 times that 2 squared, we have to use the order of operations there. The exponent has to come before the multiplying. So don't multiply 3 times 2 and get 6, and then do 6 squared. That would give you 36, which obviously is not 12. Right, you have to do the exponent first, the 2 squared, and then multiply that times the 3. Right, so it's the 4 times 3 to get 12. And then minus 2 to the third power. Well, 2 to the third power is 8, so that's going to give us a minus 8. Right, so x squared minus 2 raised to the third power is x to the 6th minus 6x to the 4th plus 12x squared minus 8. All right, so that's using that formula for that binomial to the third power. Now, again, if you forget this formula, there is a way to still get your answer. You would just have to take that x squared minus 2 to the third power, and you have to do x squared minus 2 multiplied by itself 3 times. Right, but remember, you don't just distribute that 3 and make it, well, x squared to the third minus 2 to the third, and that's my answer. You cannot distribute that exponent when you have addition or subtraction inside the parentheses. That's why we have these special formulas, and we have to actually, if we don't know the formulas, we then would have to multiply this out, right? Which is a little bit more difficult than what we had up here when it was just raised to the second power. So in this case, knowing that formula will save you a little bit of time. But again, it's not like this is impossible to do, right? It'll take you a couple minutes to work your way through this. And the way you would do it, if you forgot the formula, would be, well, let me just take 2 of these, and let me, FOIL this stuff, and then multiply all that out, and get that answer. And then once I get that answer, I take this parentheses, and I distribute it to all that stuff that's in there, and then I would get my answer, which would come out to the exact same thing as what we had up here. All right, so again, if you don't remember these formulas, there's still going to be a way to figure it out. You just have to do all that multiplying to get your answer. All right, the last one up here, 2x minus the square root of y times 2x plus the square root of y. All right, so here we have 2 binomials. They're not exactly the same, but they're close to the same, right? They both have the same terms, the 2x and the square root of y, except one has a minus square root of y, the other one has a plus square root of y. Right, so one of the special product formulas says if we have a plus b times a minus b, that equals a squared minus b squared. Right, in this case, my a is the 2x, and my b is that square root of y. Right, so if you recognize that you have 2 binomials, and they have the same terms, but one with a plus and one with a minus, you could use this little formula here to take a shortcut to getting the answer. All right, so this says that it's a squared. So my a is 2x. All right, so that's going to be 2x squared, and then minus b squared. My b is that square root of y. So it's the square root of y squared, right? So again, first thing I have to do is recognize that one of those special formulas applies to this problem because I have the same 2 terms, but one with a plus, one with a minus. So I figure out, well, this is the formula I need. Then I have to identify what's a and what's b, right? A is the first term in each, which is the 2x. B is the second term in each, which is the square root of y. And then I plug that a and the b into the other side of that formula, right? It's the a, the 2x squared, minus the b, which is the square root of y squared. And now I have to simplify this. All right, so remember, just like we saw up here, that 2x squared, both the 2 and the x are getting squared, so that's 4x squared. Right? Remember, I'm allowed to distribute the exponent into the parentheses when I have multiplication or division on the inside, not when I have addition or subtraction on the inside. All right, so that's 4x squared. And then the square root of y squared is just going to be y. Right? Remember, the square root and the square, or the second power, are opposites of each other. They cancel each other out. And so the square root of y squared, if I did the square root of y times the square root of y, I just get y. All right? So I get 4x squared minus y. That's the answer to this problem. Now, once again, if you don't recognize that this fits this formula, or if you forget what the formula is, you just go ahead and multiply it out. Right? So 2x times 2x would give you 4x squared. 2x times plus square root of y would be plus 2x square root of y. right? Negative square root of y times 2x would be negative 2x square root of y. And then negative root y times positive root y would be negative y. And those 2x square root of y's, one's plus and one's minus, so they cancel out. And so you have 4x squared minus y, which is the same thing you got here. Right, again, so using these formulas, for the ones that are raised to the third power, the formula definitely helps to save you some time and makes it a little bit easier. But those are also the hardest formulas to remember, which is unfortunate, right? But for the ones where it's raised to the second power, this one where it's just the two binomials multiplied together, knowing the formulas doesn't really help you that much as far as saving time or making it that much easier to do. I would say it might even complicate things trying to memorize these extra formulas. All right, but anyway, if you have to use the formulas, that's how you would do it. Hopefully that was helpful to you. Remember, when you're multiplying polynomials, even if there are formulas that apply, if you forget the formulas, you just have to go ahead and write it out and do all the multiplication. You can still get the answer even if you forget what the formula is.